Hey everybody, welcome back to Young Engineers of Today. Sorry about the late start there. I had some technical difficulties, but this will be up and running again. I know, Matteo. I know. Double check your. Tell you what. We'll go through Bandit 0, and then I'll give you the password for Bandit 1, and you give that a try, and we'll see if it's actually a permissions issue with your computer or if something weird was going on. But anyway. Yeah, we're going to continue with Over the Wire, and it's actually we're basically just gonna start from the beginning again, and I'm gonna talk to you guys about the terminal and things like that, so that you guys can get more comfortable with the bash. So, again, if you're on a Mac or a Linux computer, just as a reminder, the command to connect to it is just SSH, and of course we have to give it a destination, which would be bandit.labs.overthewire.org, because that's what we want to connect to. And then you would connect to it and enter in your username and password and stuff like that, and be good to go. If you're on PuTTY, you would be typing it in here. You could also save the session, which is exactly what I did here, in order to make it easier to connect to, just by giving it a name and then clicking save after putting in the host name. I'm going to delete that one. And I'm just going to go ahead and double click on my saved session. So, Bandit 0, the entire point is just to connect via SSH and open up the README file in order to get the password for level 1. The entire point of that is meant to basically walk you through the whole process of connecting to something on SSH and using simple bash commands. So if I type bandit 0, and again, bandit 0, we're now in. Let me go ahead and list everything that's here by using ls, and we just get README. You guys remember maybe what the command is in order to show the contents of a text file to the bash? Well, just in case you've forgotten, it's cat. And that's it. So we're just going to say cat readme because we have to have a target for it, right? So cat readme, enter, and there is our password. A whole bunch of characters. So let me go ahead and highlight this, and I just have to drag my mouse across it. And once I let go of the mouse button, it will have copied the entire thing. There you go, Matteo. Give that a try for Bandit 1. And that's all we need to do for Bandit 0. So let me go ahead and just open up a new session. If you're using PuTTY, you can disconnect and reopen PuTTY and then reconnect to bandit.labs.overthewire.org. And now I'm going to log in as Bandit 1. Because remember, each login represents a different level here. So we've finished Bandit 0. We're now logging in as Bandit 1. Did you paste the password that I gave you for Bandit 1? Let me just spend a moment looking at this right now, because I was looking at it earlier. Let me see here. So let's try this again. Let's try this, Mateo. So what I want you to do, oh, I just lost connection. That's okay. What I want you to do is type this into your command line and tell me what you get. I'm sorry, everybody. We're just going to spend a moment doing this because I want to make sure that we at least get everybody able to participate. It'll probably ask you whether or not you want to continue connecting, in which case you say yes. Now this is bandit 0, so your password here should be bandit 0 because it'll ask you for the password, possibly. Okay. Do you know how to get to your system preferences? Go there, and in your system preferences, check your sharing category. You know what? Let's make this even simpler. Try that. In the terminal, I mean. And then bandit 0 is your password. Yeah, okay, so that's what the problem was. The problem was you were trying to log in through SSH as the username on your computer. So in the future, whenever you're using SSH to get into really anything, it's going to be this as opposed to the regular SSH command, because your computer will assume that you're trying to log in with the username that you are currently logged into on your own computer. Really, I should have realized that sooner, but you know, sometimes these things happen. Anyway, for sure. Server unexpectedly closed network connection. So we go ahead and open up a new session. And again, we're going to connect to bandit.labs.overthewire.org. Oh, I've been sneezing a lot. Okay, bandit.labs.overthewire.org. I'm going to go ahead and hit OK. And remember, well, darn it, I'm going to have to log back into bandit 0 because I don't actually have the password anymore. But that's okay. We'll cat readme and copy paste the password again. By just highlighting it, I can copy the password. And then what I can do is I can hit exit or log out, both will work, and start a new connection to it and log in as Bandit1. Now the password for Bandit1 is going to be the contents of that README file. So using PuTTY, I can just right-click to paste, do nothing else, just right-click to paste and hit enter. Done. So now we're in Bandit1. Let's check out what we've got here, again, with ls. ls will show us the contents of a file, the current directory that we're in fact, if we just use ls. We can also, use ls and tell it to look at a specific folder and stuff like that, but we can worry about that later. We have one file here. The name of this file is a minus sign. Okay? Let's go ahead and cat minus sign. Nothing happens. I'll try typing. I can type, hit enter, and I just get it echoed back to me. This is not useful at all. So what I'm going to do is I'm going to hit Control-C in order to kill that process, basically to cancel what I was doing. And that'll bring me back to the bash, the bash input, which is what I want. So here's the problem. The minus sign is a reserved character in bash input. It's reserved for stuff known as options. Now you remember that ls command I've been using? Well, I can modify that ls command with options. So here's the tricky thing about ls. You can hide files in the bash terminal, bash command line, whatever you want to call it. And hiding files makes them invisible when you try to ls them. Except you can force ls to show you everything. It's the all option, shorthand A. Now the way I do this is I type ls, I hit space, and I type -a. And this is feeding an option into ls, which will show me everything, including hidden files. And if I hit enter, I get a bunch of extra stuff. I've got my minus, but I've also got some dots, and I've got a .bash _ logout, and a .bash rc, and a .profile. So there's some additional stuff here because I fed it the option to show everything. So we've reached a bit of an impasse. How do we look at this file? Because that minus is a reserved value, or a reserved character. Well, I'll tell you. We just have to be more explicit using bash. We have to tell it that we're looking at a file by providing it some context. In this case, the context is going to be the location of this file. I'll show you a command. pwd is short for print working directory. I'll hit that, and I'm in home/bandit1. This is just like the working directory for, just stuff on your computer. Like if I were to navigate to this VeriSign icon, I can click up here in the address bar and see that I'm in the C drive, and then program files, and then common files, and then services. And this is a hierarchy of files. A print working directory, it's the same output. It's giving us the hierarchy of directories that leads to where we are. So what we can do is we can say cat home bandit1 and then a minus and hit enter. And we actually get the outputs. But that seemed like a lot of work, right? Like there's got to be an easier way to do that. And there is, actually. You see these two right here, these two little pieces of output in the ls-a. One of them is a single period and one of them is a double period. one dot and two dots. These are called relative file paths. And they basically represent, in essence, your location, no matter where you are. So let's see here. Let's look at our file system as it stands right now. So you've got root, and then home. This isn't entirely 100% correct. I just want to, I want to add this bit here. And then inside of bandit1, we've got just our minus, right? So this is sort of what the file system looks like that we're looking at right now. And we are here logging into bandit1. What are you having trouble with then? What exactly is giving you trouble about that? Right, but like, is it giving you any results? Like, is it saying anything back at you? Is it just pretending that nothing's happening? Like, what's going on? Okay, all right. Well, I'm glad you got it to work. Okay, so anyway, we are here, right? Well, the single period and the double period represent locations. They're shortcuts, in essence. You know how you have shortcuts on your desktop that represent applications that are, you know, somewhere else on your computer? Think of these like shortcuts as well. The single period always represents where you are. The double period always represents one file level up. So let's say, instead of being here, we were actually in the home folder. Well, the single period would represent the home folder, and the double period would represent root. So it's always relative. So we can actually shorten this. If the period represents exactly where we are right now, we can type cat period / minus, and we should get the same result, right? And look at that, we do. Hey, so now we have our password for bandit2. Let me go ahead and copy this. Done. And for those of you running PuTTY, I'll give you a little shortcut. This icon up here, I know I've done it before, but I'll explain actually what's going on. If I right-click this little icon, there's an option here called Duplicate Session. And what that's going to do is it's going to open up a new session to the exact same address. It'll ask us for a login again and everything. So we can actually log into bandit2 this way by duplicating our session. We get a new window. Let's exit out of our old window. And here we're going to log in as bandit2. Enter, paste our password by right-clicking, enter one more time, and now we're in bandit2. Let's check out our contents. This is called spaces in this file name. Okay, pretty straightforward, right? This is a file called spaces in this file name. Let's check it out. That's a bit of a problem, isn't it? cat spaces, no such file or directory, cat in, no such file or directory, cat this, no such file or directory, cat file name, no such file or directory. So we got 4 error messages. What exactly happened here? Remember how the minus is a reserved character? So is the space. The space represents a way for the bash to separate distinct commands from one another, distinct things from one another. So the way to interpret this is we want it to cat, like we've been doing before, but instead of cat using cat on a file called spaces in this file name, we used a cat command on 4 separate files because it interpreted that space as, hey, this is a file name, here's a space, because here comes the next file name, and then hit this one, and here's a space because here comes the next file name, and so on and so forth. So it interpreted it as 4 different files, each named one word in this. One file called spaces, one file called in, one file called this, and one file called file name. So that doesn't really help. We need some way to tell it that this is not in fact 4 separate files, but one file with a long and not exactly helpful name in the bash. So here we go. Type cat, and then a space, and then spaces. So far so good, right? Assuming I can spell it correctly. And I'm going to hit backslash on my keyboard, and then I'm going to use space. And then I'm going to type in, and then backslash, and then space, and then this, and then backslash, and then space, and then file name. And it worked. This is because the backslash is what's known as an escape character. If we want to reference something that's a reserved character in the bash, we can throw a backslash in front of it and let it know, hey, we're not using this in its normal way. Interpret this as just like as is. Don't attach the special meaning that you normally do to it. In this case, a space is just a space. It's not a separator between different file names. By doing that, we haven't actually given it like an official endpoint for the file name. So it continues interpreting the rest of this as the rest of the file name. But that could be annoying, especially if you have something that has a ton of spaces, right? Having to type all that out. So I'll show you another thing that can be pretty useful. So I'm going to type cat, and I'm going to start typing spaces. I'm going to just hit SP, and then I'm going to hit tab on my keyboard, and boom, it auto-completed the name for me, including the appropriate escape characters. Because autocomplete is a feature that exists on the bash console. We can, in fact, autocomplete long names, which makes our lives a lot easier, you know, when we're trying to reference something, because there's a lot of typing involved in the, you know, the bash console. But yeah, so let me go ahead and copy this. We'll use this to get into Bandit 3, because as we can see here, we're Bandit 2. We'll duplicate session. Bandit 3. Right click, and we're in. ls. We have a single result, which is called in here. Notice how this single result is blue on my terminal screen. It's blue because it's a directory. And this directory is, well, it's a directory. We can navigate to it. So let me go ahead and cd or change directory to in here. And now we're in here. Notice how the bash line got a little bit longer. That's because, at least in PuTTY and in many terminals and stuff like that, it will output your current working directory, and also in order to like sort of help you know where you are a little bit more easily. If we go back up a level, because remember the double period represents up one level, we're no longer in here. We can go in here, though, and we can look at the contents inside of this. Nothing. Maybe. But remember that command I gave you earlier with the option ls-a? Remember how it also shows you hidden files? Let's give it a try. Boop. Hey, look at that. There's a file called .hidden. That's how you hide things, is put a period in front of it. So, interesting. Cat .h tab. Autocomplete. Enter. Look at that. There is our password. So let me go ahead and copy that one as well. And now we're going to duplicate the session one more time. We're going to exit out of this one. We're going to log in as bandit4. And we're in ls. Look at that. In here exists again. cd in here. ls. Now we got a whole bunch of files. Files 0 through 9. In fact, we got 10 files. Which one could it be? Well, let's go ahead and check out bandit 4 through to 5. The password for the next level is stored in the only human readable file in the in here directory. Tip, if your terminal is messed up, try the reset command. Well, that's a bit vague, isn't it? Well, no matter. Let's go ahead and check out file 0. And remember, I'm doing the period and the backslash beforehand because these all start with a minus sign, which is a reserved character, and we want to, or excuse me, the period and the forward slash, because this is a reserved character, and we want to make sure that we are using, we're telling it where it is. And we get this really weird output here. Like this right here is super strange. Now, I don't know about you, but that doesn't seem like human readable to me. So, okay. Why don't we try? Why don't we try file 1? Now I'll teach you another thing that's useful. You can hit the up key, the up arrow on your keyboard to go back to the last typed command. And in fact, you can scroll through your entire history by just repeatedly hitting up. Now I can't go too far because each one of these has been a separate session, which means that there's not much saved in the history. But if I had like a very long terminal session, I could just like hold the up arrow and scroll through a whole bunch of different like commands that I've been using. So let's change this to file 1. Again, bunch of nonsense, bunch of gibberish, not really helpful. There's got to be an easier way to do this. Well, there is. There's a command called file. And file, when you give it a particular file, will give you the file type. And in fact, we can go through all these individually, but we can also use another little trick. We can say file, and then a period, and a forward slash, and an asterisk, and hit enter. And in fact, we get outputs on everything. Look at all these data files, and there's one called ASCII text. Well, we've been reading text files so far, right? Which, you know, don't worry about the ASCII part right here. That's just a protocol for letters and stuff. But one of these things is not like the others. One of these things just doesn't belong. This one seems like a pretty promising lead. Now, what exactly did I do here with this? Well, the asterisk is another shortcut. The asterisk represents, or is called, a wildcard. And it's basically a way you can search for things more easily, sort of, kind of. So let's look at it like this. So we've got file 00, file 01, file 02, file 03, file 04, file 05, file 06, file 07, file 08, file 09. What do all of these have in common? Anything in particular? Well, they all have the word file in common, right? They all have file in their name. And in fact, we can dissect that a little bit further. They all have file and then a single zero following it in their file name. File 0, file 0, file 0, file 0, so on and so forth. Well, we can wildcard that. See, we can ask it for file 0, and then an asterisk, and it will give us the results for everything that starts with file 0 and has any number of characters after that. So all of these files are valid for that wildcard. Now let's say, for instance, we had file 10, file 11, file 12, file 13, file 14, so on and so forth. Because this is file 0 and then an asterisk, none of these are valid because they start with file 1, not file 0. These are all valid, though, because they all start with file 0. Now, if we were to expand our search and just have it be file and then a wildcard, we would in fact get all of these because all of them start with file. The numbers afterwards don't matter. In this case, because we used a wildcard here, as opposed to putting a 0 before it. So there's that. And that will help you sort of broaden your capabilities with the terminal. Now, the reason why I did this is because this gives us everything that's inside of the folder that we're currently in. Because remember, the one thing that is sort of filtering our results is it has to start with file 0. If we don't put anything in front of the wildcard, we get the results for all of the files in that folder. So let's go ahead and cat file 07. And look at that. We've got something that looks suspiciously like a password. So I'm going to go ahead and select it for copying. And then I'm going to duplicate session. I'm going to go ahead and start a bandit5 session and right-click to paste. Enter. Exit. Whoops. All right, so ls. Just like before, we've got an in here. cd in here. What about spaces in this file name? Right. What about it? Okay, yeah. Again, what is your issue, though? That's what I'm trying to say. Okay. I did. Try auto-completing it or using the escape character. Remember, tab is your autocomplete. Looks like you maybe got it. Okay, so now we're in the in here file. That's a lot of results. What are we looking for here? Password for the next level is stored in a file somewhere under the in here directory and has all of the following properties. It's human readable, 1033 bytes in size, and it is not executable. Well, based on this one alone, this one gives us a clue, because remember that we had to look for a human readable file and the in here directory for the last one. So more than likely, this is going to be a text file, right? In fact, that ASCII text file. Or ask2, depending upon who you ask. No pun intended. So it's going to be a text file as opposed to a data file like we were getting before. The 1033 bytes in size, though, that one's interesting. Because let's go into, I don't know, maybe here, 00. And let's do our whole file, all the contents. We've got a few different ASCII text files, and it says with very long lines. It just gives us a little bit more information. So we can immediately rule out the data ones because we know that those are not, in fact, useful files. We want to make sure that we are only looking at ASCII text files. So that immediately rules out 2 of the 6 files that exist inside this folder. Now I'm about to tell you about DU. DU is another command which is short for disk usage. So we're going to say DU, and we're going to do the same thing, period, / asterisk, in order to give us the disk usage of everything that exists here. Okay, so files that are green mean that they're, oh, yeah. Hold on. Well, let's just do ls. So I believe those are, I couldn't exactly tell you for sure. I think they represent executable files. Yeah, I think they're executable files, and I think that's what it means. Is if they're executable, they're green. So we're looking for ones that are not green. Okay, how do you interpret that error message, Matteo? Think about it. What is it? Just like take the sentence apart. In here is a directory. What do you think that means? What's a directory? Close. Take that first part of that, the double period part. What does that represent? Next thing up, like a folder, right? A folder? What's a synonym for folder in computer parlance? If you're navigating folders, you might also be navigating. Yeah. So why do you think you're unable to cat in here? What? No. Cat reads text files, right? Well, just files in general. Files are not directories, correct? So what do you think you need to do with in here? Why do you think it's called in here? Do you remember do you remember how to change directories? Well, I'll give you a hint. It is basically the initials for change directory, which is essentially the answer, but you know. Yep. So what do you think you're going to do? Yep. And there you go. You might have to do something special with ls just for the future. But okay, so yeah, green files represent executables. If it's not green, it's not an executable. Just so you know. So that's something you're going to want to, keep in mind. So I'm gonna change directory up a level. Oh wait, no, sorry. Before I get ahead of myself, du, the disk usage. And I get this 4, 12, 8, 8, 8, 4, and these are the different files that exist. Now 4 and 12 and whatever, 4 and 12 and 8 what? What exactly does that mean? We need 1,033 bytes in size. So these are, what, they're tiny? Well, things are a little bit different with this. So let me go ahead and let me show you another command that's going to help you out a lot when navigating the bash. It is the man command, short for, sorry, I had to sneeze, short for manual. So anytime you want more information about a command, you can type man to get where? I mean, I'm not anywhere special. What exactly? I'm just inside one of them. Maybe here. Oh, I just typed the name of the file. Since it was green, it's an executable, which gives you some weird output, and tries to run it like an executable. But like, don't even worry about that. That's the whole thing. Like, we don't want an executable. But I was just showing that that's how you can tell whether or not it's an executable. It's green, and if you type in the file name, it will run to the best of its ability, which in this case is not very well. So yes, man. In this case, we want the manual for du, or disk usage. So man space du, enter. And we get a whole bunch of information about du, including all of the possible options for it. So we can look at all of these options and see, like, okay, so description, summarize disk usage of each file recursively for directories. Mandatory arguments to long options are mandatory for short options too. Which is, don't even really worry about that, what I mean right now. But like, let's go ahead and check out these options. So -0 or null is end each output line with 0 byte rather than new line. -A is write counts for all files, not just directories. Apparent size is to print parent sizes rather than disk usage. Although the apparent size is usually smaller, it may be larger to blah, 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 blah. How about this one? Minus lowercase b, which is equivalent to apparent size, block size equals 1. But we're interested in the fact that it's referred to as bytes. So let's try du minus lowercase b period / asterisk. Hey, now we're getting byte output. 1,033 bytes in size. We know that none of these fit the bill because that's 1,039, 9,388, 7,378, 6,118, 6,850, 1915, blah, blah, blah. What's up, Mateo? That is your bash command line. It means that you are currently in the in here directory. Can't cat in here because it's a directory, right? Did you try LSing? There's no, see, hold on for a second. Think about what's going on here. Like think about the commands you've thrown out. You know cat in here is not going to work, right? You know that because it's a directory and you can't cat directories. You can't cd directory because there's no directory called that, right? Like, you know, spend a little bit of time and go, okay, so, you know, why would this command not work? You know what I mean? Because you have all the building blocks necessary in order to understand why you might want to or not want to do something. So I'm assuming you're running into a roadblock because you've been using ls and you haven't been getting any results, right? Like you've just been getting the command line again. Hey, what does that last one look like? Mm-hmm. Maybe try catting it. You gotta put a space in there. And also it's not minus hidden. See how there's a period in front of it? There you go. Okay, so we've just looked at the disk usage for all of the files inside of maybe here 00. So far, none of them are culprits, right? Sorry, I'm just going to run a few minutes over because I know I was a few minutes late coming in. So we'll go until about 3 or 4 after, and then we'll do the poll questions and everything. So what I did was I went up a level by using change directory and then the double period, because remember the double period is a relative directory representing, or like a relative link or whatever you want to call it, representing one level up from where you are. So I navigated one level up by using cd ... Now we'll look in here. Well, this actually kind of makes things a little bit more daunting because we have to look for human readable files of a specific size in each of these. 00, 01, 02, 03, 04, 05, all the way up to 19. Well, that seems like Seems like a lot of work, right? There's got to be an easier way to do this. But if we check the bandit level 5 to level 6 goal right here, we also have commands you may need to solve this level. One of them is find. Curiouser and curiouser. Let me go ahead and find. Well, I don't know what to look for yet, so let's try manual find. Hey, now find is a pretty big command, and it's going to have a lot of information on it. So in order to just save you some time, well, A, you could Google it, but B, I was being a little, sort of being a little intentionally difficult with the middle schoolers to try and get them to sort of Google the answer to this. But I'm just going to go ahead and I'm going to walk through this little part as well. So here's what we're interested in. We're interested in size, because we want to look for a file of a certain size. And if we can find all of the files that have that specific size, we can narrow down our search significantly. And if we could search through all of the files, then we'll save ourselves a lot of time by doing it with one command, right? So this option is structured as such: size n. And then as you can see, CWBKMG. These are little suffixes that you can put after the number for the size. So to sort of break this down a little bit more, we're going to do find size. N is going to be our number, our size, so 1033. But 1033 what? Let's see here. B for 512 byte blocks. This is the default if no suffix is used. C for bytes. W for 2 byte words. K for kilobytes, M for megabytes, and G for gigabytes. So we want something that's 1033 bytes in size. So C is going to be our, our go-to here. So there you go. And of course, we have to search for it in a location too, right? Let's scroll back up and see how this is structured. So find, and then we got our options, our path, and our expression. So this is an expression, I believe. No, it's not. It's a test. Let me see here. Yeah, it's a test. So let's see where tests fit in. Tests fit in this front part here. So it looks like we're just going to be searching in our current location right after that. So let's give it a try. Find size 1033 C period / asterisk. Whoops, I have it backwards. See, I knew that because of the way that it gave me a result. It gave me a syntax hint, as opposed to just saying didn't find anything or whatever. So I put this in, find period / asterisk size 1033C, and I got one result back, maybe Hero 7 file 2. Huh, okay. Let's go ahead and get the file type of maybe here 07 file 2. Notice how I'm not even navigating to that folder. I'm just asking for the file type of the file in that location. You can do this in the terminal. It's like double-clicking on something that's inside several folders. Look at that ASCII text with very long lines. Huh. We know it's not an executable. Well, at least we hope it's not an executable. Let's try running it. Permission denied. It's not an executable. Awesome. Let's cat it then. And we get this result. We get the password, and then we got a whole bunch of, I guess, white space after it. And that's our password to get into Bandit 6. So, okay. I'm going to go ahead and call it a day here, just because I'm going to give you, I believe in you, Mateo. Work through it. Get to Bandit 5. Get to Bandit 6, in fact. I know you can do it. I'm going to go ahead and do the poll questions, and then we'll leave it open for question and answer time afterwards. And yeah, so let me go ahead and get that started.